Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. We have used many variables and functions in writing strategy examples before. So, what are the specific rules for naming these variables and functions? Today we will learn about the concept of markers in the Python language. Generally speaking, a marker is used as the name of a function or variable. There are several general naming rules for markers. We can jump to the Python language test code on the FMZ platform strategy library for demonstration. First of all, the marker must be named with uppercase from A to Z letters or lowercase from A to Z letters, like this. Or with underscore as the first character of the marker, like this. Secondly, the characters after the first character of the marker can be letters, underscore, or numbers. And the marker naming is also case sensitive. Here we demonstrate with a simple strategy. Name of a variable, FMZ, var. Assign a string to the variable. And then name of a variable, underscore, FMZ, var. Start with an underscore. It starts with an underscore and assign a value to underscore FMZ. And continue to name the variable. Values can be added to the variable name, such as FMZ 666 var, which is assigned to FMZ 66 var. We can also take an identifier. We can also take a marker function name and assign it to function name here. Similarly, if we name some constants, we can also use all uppercase letters. For example, max learn means learn mechanism. We let it equal to 1 here. The variable named by this marker can be assigned as a constant. It can be assigned to the value of 1. We can also declare a variable in lowercase and assign a value to it. For example, we write another marker to name a variable maxLearn in lowercase. Let it equal to 2. And we can also write max_learn without the underscore and assign it the value of 99 here. We can give the marker a name to be used as the name of the color value of this variable. For example, give the marker the name red and assign it a color value. We use the runtime log function to print out all the above variables. With the red color value at the end here. And it will resolve the last color value during printing and render all the log output in red, which can be seen during running. Finally, in order not to overprint the information, we can add another function, runtime error. Then we will throw an error to stop it here. That is, let it stop after printing. We can add an exchange object after the input for convenient observation. Here we have added the Binance platform. Here we click backtest. And we can see that all the variables data we just named is printed out in the log area. We can see that there is an error thrown to stop it here. We can see that a string is printed out from the first to the fourth variable. The fifth variable prints the value of 1 here. The sixth variable prints out the value of 2, and the last variable printed out the value of 99 here. This last color value is passed as a color setting for the entire log. It doesn't print out a specific value. Of course, we can put this color value a bit earlier. Here. We can put it here. Then it will not pass this color to this color value, and it will print out the color value. We can click Backtest to try it. Here we can see in the log area, the color value is printed out in the log information value. Here. This color value is FF5252. On FMZ, the color values are displayed in hexadecimal format. Then we can go back to the code page. All of these are legal marker declarations, but what kind of marker declarations are illegal? In the Pine language, it is not allowed to start with a number as a marker. For example, we name 3 bars down with a value of 99. At this point, if we click Backtest, it will throw out an error here. So whether the marker is used as a constant, variable or function name, its first character must be a letter or an underscore. And using a numeric value as the first character will report an error absolutely. Of course, Pine language is the same as other programming languages. There are some writing naming suggestions and some conventions. Usually these are not mandatory requirements, but it is usually recommended to follow the following specifications when naming the markers. For example, when naming with all uppercase letters, it is usually used to name constants, such as maxlearn equals to 99. Which we just named. When naming with all lowercase letters, it can be used as a function name, or variable name. When naming with lowercase letters, there is also a conventional rule, and we generally use the lower camel case to name them. That is, the first word starts with a lowercase letter and the first letter of the second word starts with an uppercase letter. For example, if we name first name here, we can see that it's composed of two words, first and name. The first word starts with a lowercase letter, and the second word starts with an uppercase letter, so that it's easy to distinguish and to see the literal meaning of this variable at a glance. If we use all lowercase, it is not so easy to distinguish. So we use the camel naming method to make it easier to understand the code. For example, if we name last name, let it equals to xxx, and let the first name equals to y. Don't forget to quote them. We can write a few more examples. For example, we name a color constant green color. We use a color value for CAF50 here to assign a value to this color variable. As for the color value, we can check the reference table on the internet. And then let's name a max look back constant and use it to record a maximum look back period. We will see many variables like this in Python language strategy code later. We can also name an indicator line parameter fast length and let it equal to 7. Many people use fast length, slow length, and so on as a variable for the average line parameter when calculating the average line. We can also name the function. For example, we name our function 0, 1 here. The parameter is bool value, and then we write the function body. The function body we can write in a line with a ternary expression as its return value. That is, if the Boolean value passed in is true, it returns to 1. If it's false, it returns to 0 here. Next, let's take a look at how to use the operators in the Python language. The operators in the Python language are used to construct some operation symbols of expressions. And expressions are calculation rules designed for certain calculation purpose when we write strategies. The operators in the Python language are classified according to their functions, and there are generally 6 types. The first is assignment operator. The second is arithmetic operator. The third is comparison operator. The fourth is logical operator, and the fifth is the ternary conditional operator. And the sixth is the history operator. There are some subtle differences in the use of the Python language operators on FMZ and TradingView, where the restrictions are a bit broader and more relaxed on FMZ. In TradingView tutorial, for example, There is such a code which is from the TradingView v5 version. It is the beginning of an indicator test. We write learn input then. Assign it with the input int function, name it as length. We use a set parameter function here actually. Initialize it to 14 here. Then we proceed to declare a variable factor, which is a judgment of the expression. Here we take two variables, input and factor, learn input and factor. And then we use the values of these two variables for arithmetic. And then we assign a value to the third variable. We declare a fourth variable MA and use TAEMA built-in function to perform the operation. We use the closing price data series to calculate the EMA indicator. And what are the specific parameters of the EMA indicator? We use the variable adjusted length to calculate the average of several days or several periods. Finally, we use the plot function to draw the MA averages. So that's the code. However, if the code runs on TradingView, it will report an error here. mainly because the type of the return value of the arithmetic operation in the step adjusted length equals to input, learn input, and factor does not match the type of the period parameter that is requested to be passed in the TAEMA function. Since our FMZ platform does not have any strict restrictions on the type of the Python language, this code works fine on FMZ. And we can click Backtest. Here we can see on the chart the code running properly, and there is data output on the subchart here. Next, we will learn the use and details of each operator in details. First, we will learn about the assignment operators, which are of two types. One uses the equal sign to assign a value, such as the variable a equals to 1. And the other is this. We have seen the first type of assignment operator many times before, but we have rarely used the second one before. Let's start with the first one here. The assignment operator is used to assign a value to a variable when it is initialized or declared. For example, we use the equal sign to assign a value. That is, each variable on the k-line bar starts with this value after the assignment. Let's use an example for demonstration. We declare a variable a and assign it with the built-in variable close. Then we declare a variable b here and assign it with the value of 10,000. Declare a variable c and assign it with the string text. And declare a variable d, assign it with the color value, green. After the assignment, we can use the plot function to draw these variables. Draw the first variable a, name it as a here. And draw the second variable b, name it as b. We use the plot char function to output the variable c to the k-line bar, which is displayed as a character. Write the first parameter as true here, which means it is output on each k-line bar, and we name it as C here. Convert the parameter char with the string to string here. Set the color value. We use the variable D as the parameter and let it display on the main chart. And here we click on backtest. And we can see that the content is exported to the chart. A green test string is outputted on each k-line bar here, and the values below are printed. We can see the line B. It is always 10,000 here. And the line A is synchronized with the closing price of the k-line bar. Let's go back to the strategy code page. What we need to notice is to assign a value to A with the code with the close built-in variable. That is, the A on each bar is the closing price on the current k-line bar. It is subject to change. Other variables B, C, and D are unchanged. That is, each round of code execution assigns a value to a variable with a fixed value, and only the built-in variable close follows each k-line bar and changes constantly. The equal sign is the simplest and most commonly used to assign values. Next, we'll talk about the less used colon equal sign assignment operator, which is very important in the Python language. And we will focus on it in this section. Colon equal sign is used to reassign values to existing variables, which can be simply understood that the use of colon equal sign operator to assign values is to modify the value of such variables that have been declared and initialized. If we use the colon equal sign operator to assign values to uninitialized or declared variables, it will cause errors. For example, we directly write A colon equals to 0, which means that A is only assigned in this place and not initialized elsewhere. At this time, we click backtest. We can see that it reports an error here. This operator is used to modify existing variables after they have been declared or initialized, and it cannot be assigned directly like this. Let's write a test code here. First, declare a variable a and assign it with the built-in variable close more than open. When this expression is true, a is true. Otherwise, a is false. Then we initialize the variable b, let it equals to 0. Use if to determine a here. If a is true, we execute the code block b. That is, accumulate b by 1 here. Finally, we use the plot function to draw b, name it as b. So what does this code do? When close is greater than open, it represents the closing price. The closing price of this k-line bar is greater than the opening price, indicating that it is a positive line. If A is true and the condition holds, we will let B to accumulate, and the code will run until the rightmost side of the chart, which is equivalent to calculating how many positive lines there are in this chart. Whenever a bar is positive, we add 1 to the variable b. Here we click on the backtest. We can see on the chart the variable b. The variable b here does not accumulate. Actually, it is always hovering between 0 and 1. 0 and 1. If it's positive, b is 1 here. And if it's negative, the k-line bar is negative, b is 0. The reason is that the local code block, where we write the accumulation operation, it does accumulate. But every time the strategy code is executed, this place will reinitialize the b to 0. That is, every time it accumulates and resumes, it does not continue to accumulate. This is needed to pay great attention to if we are beginners of Python language. If we are not familiar with the initialization or naming of the variable, we will often get in this trouble. Then, how to make the code run normally according to the way we want it? The answer will be revealed in the next video. Finally, if you find our tutorial video helpful, don't forget to like, follow, and repost our videos. Thank you. See you next lesson.